Hello everyone. Today I'm going to be going over a couple examples from chapter 11.5, and I'm going to be touching on plane equations in standard and general form, angles between two planes, parametric equations, a little bit of the cross and dot product, as well as finding normal vectors. I hope you all find this review helpful and beneficial. Okay, let's start. Question number 49. Find equation of a plane passing through 3 points. These are our 3 points listed right here. First thing I will do is label them PQ and R. And I'm going to find my PQ vector, which is 3 minus 2 is 2. 2 minus 2 is 0. 1 minus 3 is negative 2. Then I will find my PR vector, which is negative 1 minus 1, which is negative 2. Negative 2 minus 2 is negative 4. 2 minus 3 is negative 1. So from here, we need our normal vector, which is perpendicular to the plane everywhere. We get this by the cross product of the two vectors that we found. So our normal vector is the cross product of PQ and PR. Quick review of the cross product, IJK on the top. List our PQ, 2, 0, negative 2, negative 2, negative 4, negative 1. Okay, starting with 0 times negative 1 is 0, minus negative 4 times negative 2 is 8. That's our I. We start with a positive, so this one will be negative. Then we have negative 2, negative 1. 2 times negative 1 minus 4j, now positive. And we are left with 2 times negative 4, negative 8 minus 0k. So our normal vector is negative 8i, negative 6 plus 6j minus 8k. Okay, so from here, we have our standard form equation, a times x minus x1 plus b times y minus y1 plus c times z minus z1 equals 0. Our A, B, and C is right here, A, B, and C. And all we have to do is pick a point, any point, and plug in to get our standard form equation. Minus 8, x minus, I'll pick for the first point, 1, 2, 3. 8 minus 1 plus b, which is 6, y minus 2, plus c, which is negative 8, z minus 3 equals 0. So this is our standard form. Now general form, ax plus by plus cz plus d equals 0. This is simply, you can just by regrouping this, we'll get minus 8x plus 8 plus 6y minus 12 minus 8z plus 24 equals 0, minus 8x plus 6y minus 8z. 8 plus negative 12 is negative 4 plus 24 plus 20 equals 0. And there's our general form. Okay? All right, moving on to the next question. All right, find the angle between two planes. Okay, so we need to know what our formula is. Angle between two planes is the dot product of our normal vectors, and the absolute value, so make sure you always remember that, equals the magnitude of the normal vectors multiplied by each other times cosine theta. So let's start by finding our normal vectors. So our first normal vector, our first plane will be 3, 2, -1. Our second normal vector is 1, -4, 2. So that's very simple. -4, 2. Okay, now the dot product. The dot product, if you recall, is just multiplying the I components together, the J and the K, and adding them together. So 3 times 1, dot product here. 3 times 1 is 3, minus 8 minus 2 equals -5 equals -7. Okay, so now we still need the magnitude. So the magnitude of the first normal vector is 3 squared plus 2 squared plus -1 squared, which gives us 9 plus 4, 13 plus 1, square root of 14. Magnitude of the second normal vector is 1 squared plus -4 squared plus 2 squared, which is 1 plus 16, 17 plus 4 is 21. Okay, let's plug this into our formula. The dot product, the normal vector is -7, but the absolute value, so we'll put in +7. We have our first magnitude, multiply second magnitude, and cosine theta. Okay, reworking this can be square root of 294 equals cosine theta. Now to get your angle, all you have to do is into your calculator, plug in cosine to the -1, put this in, and then theta will be 65.91 degrees. Okay, so that's the first part. Now we want to find the line of intersection between these two planes. So the first thing that we need to do is find a point of intersection. By doing that, all we have to do is add these vectors together. I'm sorry, these two planes together, not vector. Okay, looking at this, I'm going to try to remove a variable, and I think what I want to do is multiply the bottom by -3. So that's going to give me -3x plus 12y minus 6z equals 0. Add these together, x's cancel out, I get 14y minus 6 plus -1 is -7z, 7 plus 0 is 7. Okay, here we got 14y equals, move this over, 7z plus 7. So you can choose whatever you want on the right for the right variable. I think I'm going to let z be 1 just to keep it simple. So if let z equals 1, if z is 1, then we get 14y equals 14, which gives us y equals 1. Okay, so we have z equals 1, y equals 1. To find x, all you have to do is plug it into one of the planes to get your value. Let's see, 3x plus 2 times 1 minus 1 equals 7. So 3x plus 2 minus 1 equals 7. Let's see, 3x equals 6. X equals 2. So our point of intersection is 2, 1, 1. Okay, now we need a direction vector. The way that we find a direction vector is by taking the cross product of our normal vectors. So going up to the top, we can see these are our two normal vectors, and taking the cross product, okay, we get 3, 2, -1, 1, negative 4, 2. Let's see, we got 4 minus 4i minus 6 minus negative 1j plus minus 12 minus 2. Okay, giving us the direction vector of 0i minus 7j minus 14k. All right, so from here, we have our point of intersection and we have our direction vector. With that information, we can just plug it into the parametric equations formula. So our x equals the point that we found, which is 2, plus 0t. Then we have y equals 1 minus 7t. Z equals, what is our z? Oh, 1 minus 14t. So these are our parametric equations. So that's that. I would say the most difficult part for me in learning these processes was that there are many steps and there's many formulas. It can get very confusing. But as with anything in math courses, the more we practice, the easier it becomes. So this is actually, I think, pretty simple, but if we do the steps over and over again, it clicks and it's not so bad. So good luck, everybody, and I hope you all do well in the final. Thank you.